Hello, this video continues our lesson on how to use the short-run New Keynesian model to obtain numerical results. This is part 2. We advise you go back and look at part 1 of this video because you're kind of jumping in the middle and you may find some of the things we're talking about a little bit difficult to understand. I do want to review a tiny bit from the previous video, because in the previous video we learned about how shocks of different kinds affected the output gap, the equilibrium output gap, and we write that as gap EQ. We learned that there's a negative relationship between the expectations gap of inflation and the output gap. So if inflation expectations rise relative to the target inflation, we have a positive expectations gap, then what will happen is that the central bank, in order to bolster its credibility, will raise interest rates, and that's going to squeeze out demand, and that's going to reduce the output gap. Conversely, if we have a decrease in the expectations gap, if people expect inflation to be lower than the target, then the central bank will have to reduce interest rates and encourage aggregate demand, and that'll mean an increase in the output gap. So there's a negative relationship here between the expectations gap and the output gap. In terms of productivity-based shocks, okay, it shouldn't be any surprise that there's a positive relationship when we have a favorable shock, a rightward shift of the short-run aggregate supply curve, let's say a reduction in oil prices or a more favorable harvest, that's going to increase the output gap. Alternatively, if we have an adverse shift, an adverse shock, that's a leftward shift of the short-run aggregate supply curve, that's going to reduce our output gap. So, for example, if oil prices go up, then the output gap will go down. Once again, this happens partly through the interest rate mechanism. So if we have a favorable supply shock, the central bank can reduce interest rates. If we have an adverse supply shock, the central bank will raise interest rates. Our third effect here is the aggregate demand effect. That also shouldn't be a surprise that we have a positive relationship. So if we have an increase in aggregate demand as reflected in a rightward shift of the IS curve, that's going to increase the output gap. And if we have a leftward shift of the IS curve as reflected in reflecting a decrease in aggregate demand, that will decrease the output gap. Now, as we learned, and we'll learn a little bit more, that the equilibrium increase in the output gap is going to be less than the shock, the magnitude of the shift to the IS curve. Why? Because when we have an increase in aggregate demand, the central bank that stays on its Taylor rule will raise interest rates, and it will squeeze out some of that aggregate demand. Conversely, if we have a decrease in aggregate demand, a leftward shift of the IS curve, that means that the central bank will reduce interest rates. So the magnitude of the shift here in the gap is going to be less than the magnitude of the original shift in the IS curve. Okay. Lastly, discretionary monetary policy. You shouldn't be any surprise that that has a negative effect when the central bank raises interest rates on a discretionary basis. We'll see that's a leftward shift to the RT curve. That's going to mean that the demand elements, consumption, and especially investment, are going to be squeezed out, and that's going to reduce the output gap. Alternatively, if we have a discretionary loosening, that's a reduction in interest rates, that's going to mean that the central bank is encouraging more demand, and that'll increase the output gap. So what we did in the last slide was we took these common sense notions and we showed that actually they were borne out in the mathematics. So now our step 2, we want to get equilibrium, the equilibrium real interest rate, we want to get the equilibrium inflation rate, and then we want to get the equilibrium nominal interest rate. How do we do that? Well, if we already did this calculation here for the gap, then we take the equilibrium gap along with all of the other elements of these equations and we plug them in. So here in the Taylor rule, we plug in the equilibrium output gap alongside our natural rate of interest, our expectations gap, and our assumption for shock to the short-run aggregate supply curve, the PBS, and any discretionary elements to monetary policy, and that will give us our real interest rate. And then over here, this is our Phillips curve. We plug in our expected inflation, our equilibrium gap, and our productivity-based shock to the short-run aggregate supply curve, and we will get our equilibrium inflation. And finally, to get the nominal rate of interest, we're going to calculate this the easy way. We're just going to take the real rate of interest plus the inflation rate, and that'll get us the nominal interest rate. So let's look at an example that we've done here. Okay, this will be actually a familiar example here. Over here on the left-hand column here, this is the baseline assumption for shocks. These are all the shocks. Productivity-based shocks, that's the aggregate, short-run aggregate supply curve. Here's the expected inflation. Here's the target inflation rate. Here is the autonomous shock to the IS curve, which is aggregate demand, and here is discretionary monetary policy along the RT curve, and we can see that expectations are aligned with the target. So here we are, 2.4, 2.4, so there's no expectations gap, and there's no other shocks. Now it turns out that in our alternative scenarios, we're going to be keeping expectations aligned with the target. So this is the same as this, and this is the same as that. So there's no expectations gap in any of our alternative scenarios. Our first alternative scenario is simply an increase in aggregate demand, and there's going to be no monetary accommodation. So we're going to have 1.5% increase in aggregate demand relative to, or as a percent of potential output. Okay, and that's going to be our rightward shift in the IS curve. And then here in alternative 2, we're going to have that same increase in aggregate demand, but now we're going to suppose that the central bank accommodates that. And how does it accommodate that? By lowering interest rates on a discretionary basis. Okay, so you can see here, if we move down, we have calculated all of the elements in the numerator, and actually this is a pretty easy example because we have no expectations gap, so that element is 0. We have no supply shock, so that element is 0. We have only an aggregate demand shock, and you remember that we have to adjust this first by this coefficient, which is negative, so a positive times a positive is a negative, and the same here, we have 0 discretionary monetary policy. So that's the minus 2.5 and have a 0 here. Now look over here, we have the same term here, but we also have our discretionary monetary policy. So now if we go back to our equation, remember that we have to add this, subtract this, add this, and we do that, and what do we find? We find that the output gap, the equilibrium output gap under our first alternative scenario is 1.1%, and our equilibrium output gap under our second scenario is 1.7%. Now, this ought to make sense to you because in this first scenario, yes, aggregate demand increased, but the central bank it stayed on its Taylor rule, and we're going to find in a second that the central bank raised interest rates in alternative 1 when we compare this to the baseline. And we're going to find here that the central bank, because it did a discretionary loosening, it actually it offset any effect of the Taylor rule, and it kept interest rates more or less constant in real terms relative to the baseline. So it turns out that we plugged in our equilibrium output gap into our equations for real interest rate, inflation, nominal interest rate, and what do we find? That here in alternative one, where we had no monetary accommodation, our interest rate rose, our real interest rate rose from 2.8%, the natural interest rate in the baseline, to 3.6%, which is a pretty sizable hike. Okay, so that's squeezing off some of that additional demand that we found was coming from our shock to aggregate demand here. So we were squeezing off some demand here. Now you'll see over here in alternative two, because the central bank accommodated with a reduction in the nominal interest rate, or relative to what it would have done on the Taylor rule, it kept real interest rates constant at 2.8%. So you can see why the output gap is higher here than here, because real interest rates unchanged from the baseline in scenario 2, but higher than the baseline in scenario 1. Okay? Now we can also see the effects on inflation. It shouldn't surprise you that in both scenarios inflation rises, but inflation rises by more in scenario 2, than in scenario 1. Why? Well, we eased up on the monetary policy. So looser monetary policy, more demand, higher inflation. Okay? Now, you'll see here that in both cases, the central bank had to raise the nominal interest rate. Why? Because the inflation rate rose. So we see an increase in the nominal interest rate here from 5.2% in the baseline to 6.6%. And we see in alternative 2 that yes, the nominal interest rate was increased, but by much less. In fact, by about 50 basis points. Okay? So finally, how do we get a dollar figure for output? Remember that this is potential output. Okay? This is the baseline scenario, natural rate of interest, and potential output. We take the potential output times 1 plus the output gap to get our figures, our dollar figures for output in alternative 1 and alternative 2. So we had a 1.1% increase in output relative to the baseline. So that raised our output from 13,206 to 13,355, a little bit over 100 and let's say $50 billion. And then we over here we have 13 trillion, 431 billion, and that's even higher. So this is 13,206 billion, 13,355 billion, and 13,431 billion dollars. Okay, that's a very easy calculation. So now the last slide I just want to show you. You want to know how we got these parameters. Well, these are the very same parameters. These are sort of the ingredients of our forecast. These are our assumptions. So you can see here that we have the marginal propensity to save, marginal propensity to import. We have our parameters from the Taylor rule. We have 1 over the short run aggregate supply elasticity. We have summed up here the effects of the interest rate on consumption and investment, and we have, well, this is another parameter from our short run Taylor rule. This is our response of the interest rate, monetary policy, to changes in the output gap. Okay, so this is our compound parameter here, our augmented multiplier. And you can see that our natural rate of interest was assumed to be 2.8%. Our potential output was assumed to be 13,206 billion, and our target rate of inflation was assumed to be 2.4%. Okay, so the model can do this for you, but We recommend that you actually do some of the exercises so that this is not such a black box for you. And these exercises are implemented in an Excel spreadsheet, and we think that you will have a good time doing those exercises. And that's in another video.